it will be there only if there is a change in the speed, right? And change in the speed in case of electric drives will be only during the transient states. Transient states का means starting, braking, speed reversal. So only in the transient states this torque will be required. Is this fine?
Yes, sir.
So we can say that ki under steady state this equation will be equals to how much? Will become this will becomes equals to T will be equals to TL, because under steady state this d omega by dt it will be 0. बोलो भाई.
Yes, sir.
Yes, sir.
बात कुछ समझ में आई? तो कहने का मतलब ये है कि अगर स्टेडी स्टेट में है तो मोटर विल डेवलप इक्वल्स टू द लो टॉर्क required at the shaft, right? Because there will not be any requirement of the dynamic torque. But if it is in transient state, it has to, your motor has to develop a torque that should compensate not only the low torque but also the dynamic torque, right? Is this clear, बच्चों?
Clear, sir.
Yes, sir.
सुबह सुबह की क्लास है, थोड़ा सा हो सकता है तुम्हें उठ तो गए कि अभी चाय पी रहे हो?
सर पूरा रेडी होके बैठे हैं.
Good. This is an important or let me explain you the steady state stability है. चलो मल्टी क्वाड्रेंट ऑपरेशन समझ लेते हैं, राइट? मल्टी क्वाड्रेंट ऑपरेशन कितना समय है हमारे पास?
Sir, around 10 minutes.
We have 10 minutes, right? Thank you. So multi-quadrant operation means कि your motor may be operating in any of the quadrant depending upon the torque and the speed, right? Your motor have the output in terms of torque and speed. This is the motor shaft. So at the shaft we'll have a mechanical power that will having a torque and the speed. It's a product of torque into the angular speed. Yes. Now the other thing is कि if your motor is capable of working in either direction, means if it's a reversible drive, your drive is having a capability to operate in any of the direction, then this torque could be in either direction. Also this speed could also be in either direction. So based on this there could be 4 quadrants. There could be 4 quadrants of operation. If we take speed, means your motor may be operating in a positive speed. Positive direction of the speed means it may be operating in a clockwise direction. Yes, if it is having a reversible characteristic, it can operate in anti-clockwise direction as well, right? So here we can take the speed positive, here we can take the speed negative, right? If your drive is a reversible drive. Similarly, your motor may produce a positive torque, a torque that supports the speed, direction of the speed, right? Also, your motor may create a torque that opposes the speed in which it is being working, right? Whether it is being working in the anti-clockwise direction or in clockwise direction, in whatever direction it is being working, your torque may be generated by the motor that may oppose it, right? So I think it's very clear now कि अगर जो मोटर टॉर्क है वो उसी दिशा में लगे जिस दिशा में मोटर ऑपरेट कर रही है. मान लो वो क्लॉकवाइज डायरेक्शन में घूम रही है और मोटर का जो टॉर्क है वो भी क्लॉकवाइज डायरेक्शन में है, तो व्हाट डज इट मीन? मोटर विल कंटिन्यू टू रन और इट विल स्टॉप?
Continue to run.
Continue to run, sir.
Yeah, it will continue to run. So that means it will be in motoring mode. We call it as motoring mode. Motoring, right? क्योंकि मोटर हमेशा मोटरिंग मोड में चलती रहेगी क्योंकि जो टॉर्क है मोटर का वो भी सपोर्ट कर रहा है उसको उसी डायरेक्शन में रोटेट करने के लिए, है ना? अगर मैं मान रहा हूं कि वो अभी क्लॉकवाइज डायरेक्शन में चल रही है, ठीक है? अगर वो क्लॉकवाइज डायरेक्शन में चल रही थी, है ना, वो किसी स्पीड पे रोटेट कर रही है क्लॉकवाइज डायरेक्शन में, और मोटर ने जो टॉर्क जनरेट करना शुरू किया वो उल्टी दिशा में करने लगी, उसकी अपोजिट दिशा में उसका टॉर्क अब जनरेट हो रहा है, तो विल इट कंटिन्यू टू रोटेट और विल द मोटर विल स्लोली विल कम डाउन? क्या होगा?
It will slowly
स्पीड कम
come
होने
down.
लगेगी कि चलती रहेगी मोटर?
सर ब्रेकिंग होने लगेगी।
कम होने
सर
लगेगी
ब्रेकिंग
सर।
मोड में चली जाएगी।
राइट, स्पीड कम होने लगेगी, दैट मीन्स motor will go into a braking region. So in this region you can see that speed is clockwise, it is in forward direction, but your motor torque is in opposite direction, means it is in reverse direction, right? So your motor will go into a braking region. So this is the first quadrant operation, we call it as first quadrant operation. This we call as second quadrant. And as your motion of the motor we have selected in, means if it's a reversible drive, then either it can have a clockwise movement rotation or anti-clockwise rotation. So we had to select the one as the positive direction, right? Maybe your load that is being attached to this motor, when it have a clockwise direction, it may go upward, whereas definitely then if it will have an anti-clockwise direction, it will go downwards, right? So we call it as forward motoring and this as forward braking. Now what will happen in the third quadrant? In third quadrant your motor is rotating in anti-clockwise direction, but again your torque is supporting that speed, right? वो उल्टी दिशा में घूम रही है लेकिन टॉर्क भी उसी दिशा में लग रहा है, तो मोटर will continue to run or it will slowly come down to zero speed.
सर कंटिन्यू टू रन।
Yeah, it will continue to run, but हम कह सकते हैं क्योंकि पहले वो क्लॉकवाइज डायरेक्शन में रोटेट कर रही थी, अब एंटी क्लॉकवाइज डायरेक्शन में कर रही है, तो we can call it as reverse motoring mode. We can call this mode as reverse motoring mode. Is this fine?
Yes sir.
There will be a fourth quadrant. Again your motor is rotating in anti-clockwise direction, उल्टी डायरेक्शन में है, लेकिन अब मोटर का जो टॉर्क है वो क्लॉकवाइज डायरेक्शन में, मतलब वो अब उसके उल्टे लगने लगा है, तो डेफिनेटली your motor will go into the braking mode. So we can call it as reverse braking, and this will be fourth quadrant operation. So these are the four quadrants in which your motor can work. We'll understand it in a more deeper way by considering an example of a lift, right? But we'll do it in the next class. ठीक है?
ओके सर। ओके
अभी
सर।
करना है तो बता सकते हैं, मैं एक एग्जांपल लेके बता भी सकता हूँ। बताओ
नेक्स्ट क्लास में कर लेंगे।